Hello, everyone, and welcome to today's CDCT live session. I'm Jason Rader, and I'll be your host. Today's session is on IoT, and specifically on the storage and data protection aspects of IoT. And to help me facilitate this conversation, I've got a couple of smart guys that you may recognize from previous CDCT live episodes. I've got with us today Chris Capusta, one of our principal architects. Welcome, Chris.
Thank you, Jason.
And we've got John O'Shaughnessy, another architect working with us here at CDCT. Welcome, John.
Thank you, Jason.
So, gents, for the folks who haven't necessarily watched this immediately following our previous topic on IoT, where we kind of were more general, let's kind of set the stage for what we're kind of talking about. So, in a previous session, we talked about, the Internet of Things. We talked about maybe the entire construct of that related to it. We got pretty in depth, and we've talked about some of these things in even other sessions as well. But we wanted to kind of hone in specifically on the storage and data protection aspects. So let's kind of set up what the construct would be for this. So who wants to give that a shot? Like maybe the layers, like edge. And where else?
Yeah, I'll start and let John fill in the gaps I miss here. But when we're looking at IoT, there's obviously, as you mentioned, Jason, a few different layers, and what we're seeing is we're all used to data centers of the past, and now we're seeing centers of data. It's moving out of our centralized location. The cloud was kind of the first big shift, but that's still, for argument's sake, was a collection of data in a single location availability zone. We can argue that, but now we're seeing devices at the edge that are generating a lot of data, and how do we store those? How do we protect that data? How do we secure that data? There's a lot of IoT that generates very personal data, and how do we protect that and conform to regulations and make sure it's available for processing, to bring it back to data lakes, whatever the case may be. It's a new conversation and a new struggle that we're seeing a lot of customers kind of struggle with.
To add to that, again, I think a lot of the questions come about in terms of layering and organizing and managing things. Is this a wedding cake? You talk about devices, IoT devices at an edge, whether it's a camera or a door sensor or a temperature sensor, but you're probably not going to store your data on the device itself. Well, do you shoot it directly to a single data center, or is there some intermediate device where you maybe capture all the devices for a particular location? Maybe you do some analysis there before you send it up to a single aggregate place before you make a fancy dashboard. So there's a lot of decisions to be made regarding data and IoT.
Okay. Yeah, I like that. So, and I think you both talked about kind of these. So we talked about data centers, right? And so there's data protection things that we typically, classically, to your point, Chris, think about from that perspective. Are these the same? Or, I mean, is it the same tactics that we would take just depending on where the data is located? Or is there something completely different that we've got to do to approach this stuff?
I think it's the same but different. Is the best way.
Fair enough. That's what we say.
Yeah, I mean, a lot of the strategies will carry over from what we're used to in the data center today. However, a lot of the data is different. There's a lot of time-sensitive data that's generated on these IoT devices that we really don't see in a traditional data center, especially at such large scale. There's a lot of data that lives in areas where processing has to be done at the edge because there's not connectivity to immediately transport that in real time to the cloud or to a data center for processing. So we've done a few projects where we're monitoring water on a farm, and connectivity in those rural areas is not where I can immediately ship that data somewhere to do heavy lifting processing. It's got to be done at the edge, and it's got to be protected at the edge, and especially if it's that time-sensitive data we talked about earlier. So it's very similar conversations that we've been having all of these years in traditional data center type fashions, but there's a lot of new variables that we haven't faced before that we have to account for.
And it sounds like So, when we talk about IoT, there's kind of two sides of this that we've typically talked about. There's IoT where we're trying to kind of wrangle in the stuff that's out there, and then there's IoT that was like, no, we thought this thing out, and there's specifically, this is how we're kind of implementing this solution. There's, to your point, there's some storage at the edge, maybe some processing at the edge, maybe it's in another location, but we did this on purpose is my point. And I think in that aspect, is there something in that thoughtfulness? Is there a maturity model or something along those lines from a storage perspective? Because I want to talk about the data storage first, maybe the data storage, and then we'll talk about maybe the data protection aspects of that as we go forward. But I think you kind of brought up, there's that processing that sometimes has to happen there depending on bandwidth concerns. But is there kind of a maturity that happens? Because I hear, potentially folks are like, oh, well, wait, you can just put that in the cloud. Help me along that.
Yeah, absolutely. I think the cloud is where a lot of we see a lot of these activities being tested. The cloud is easy to spin up IoT. It's easy to test IoT. It's even easy to do IoT at scale. However, when you get into these scenarios where I need real-time processing, as we mentioned, areas where connectivity is a problem, or even just the latency of shipping that data somewhere to process an expected immediate response just doesn't work out. So absolutely, it's a maturity thing. I can test in the cloud, but as I roll this out to retail stores, to the backs of trains, to farms, to the scenarios are endless here. We start to look at how do we keep secure and make that data available at the edge, and that's where things like storage really come into play. What we're used to in a traditional data center doesn't always apply at the edge. It's very hostile environments. It's environments where we would never think of sticking traditional technology. So we start to look at hardened devices and things that can ensure that availability and survive in those non-optimal conditions.
I think one of the tricks is to take your standard set of requirements. Here's a thing, we're going to get some data, we're going to store the data, and you've got to fill in the story in ways that maybe we haven't in the past, in terms of we being people who think about inside of a data center. We inherently think about, here's a thing, there's low latency because it's in the same data center as the storage, not a problem. But we don't have that anymore. We need to sort of draw it out on the whiteboard and going, thing on train, thing receiving data from train, end result. And what do we need to do to piece this all together so that the customer of this data gets what they want in the way they expect it? Because it's not their job to think of all of those pieces. It's really our job to think of all of that. And so we have to, build the processes in place to ask the right questions so that we can build the right solution for this.
Go ahead, Chris.
No, I was going to say, absolutely. John brought up a good point there. Is we talk a lot about these modern, and a few of these LinkedIn Live sessions, we've talked a lot about kind of modern IT operations, and the consistent theme was breaking down the silos between the developers and the operations and traditional IT folks. And that is a completely valid conversation in the IoT space as well, because it's not just protecting the data, but it's understanding the use and the requirements around the data. And the developers are the experts in that, and the rest of the folks are experts in how to secure that and protect that and store that. So it's a marriage between those two groups that have to happen, and then those silos have to be broken down.
I think that's definitely a gold nugget so far in this conversation. Absolutely. Is that, there's that. I always do that Jurassic Park kind of quote, as we were so concerned of whether we could, we never thought of whether we should, and capability wise, could we have put this type of processing and storage on a moving train, in the past? Maybe not. Now that we have, is this data, maybe the data is generated there. Is it protected data? Is it regulated data? Does it have to do with critical infrastructure potentially? And all of those things are maybe not what we thought of when we were just seeing if we could maybe pull it off.
Right, exactly.
One of my neighbors is an engineer designing wind farms, and we were just talking in the street yesterday as the snow started to fall about what data they were collecting at each individual turbine versus at a farm level versus at a regional level, and what they did to protect it. And so in his environment, it's all generally air-gapped SCADA systems, but they are collecting the data. And again, if those go into the wrong places, you've got somebody who's got the ability to turn off protections on a turbine. And what happens when you see 100-mile-an-hour winds is those blades are going to fly off if those things aren't controlled and slowed down and turned in the proper way and the blades feathered, et cetera. So yeah, again, we're facing things that are, maybe different than sort of the legacy insurance company storing data.
Very interesting. And we talked about, I think one of the things I have from my notes, or where we talked about this before, is, trains with drones. That was an interesting conversation. First of all, because it sounds very cool.
The future's here.
Yeah. Why don't you bring us up to speed on that concept, Chris?
Absolutely. So we've done a few projects around this across the country where traditionally these train companies will send people out to physically inspect the tracks, especially trains that are carrying things like hazardous waste. And the potential for disaster there is very high. And so what we've done is attached IoT devices to drones, and the drones will fly the tracks ahead of the train and capture that data and report any abnormalities back to not only the conductor and engineer, but also the kind of mission control, so they can stop the train and prevent a spill or an accident or anything like that. So we're taking kind of the human error and the human risk out of the equation by putting these drones out there. But to John's point around the turbines, this is very sensitive, time-sensitive data that needs to be protected across that entire data pipeline. And a lot of these trains fly in areas where there is no cell service, there is no magical 5G or Wi-Fi or anything like that to transfer this data back for processing. So that processing has to be done on device, and that data needs to be transmitted securely to the intended recipients to make sure that these accidents don't happen. And part of the solution to that is we've joked a few times, but it's a real thing, is putting a mini data center on a train. If I can transmit the data back to that to do the processing, and then later upload it to the cloud or a data center or whatever the case may be, that's one scenario. But these are kind of new waters, if you will, of putting this equipment in areas where we never would have thought of doing this in the past because of those hostile conditions. So it's definitely important to have infrastructure that can withstand those temperature fluctuations. There is no filtered air on the back of a train or anything like that. So that data is important, and it's got to get to its intended recipients securely.
You talked about data hardening, and what you just mentioned. It's some stuff that, I never thought about, certain aspects of this as we, kind of talk about these things. But, in the past, like, I know with like wireless access points and those kinds of things being pushed out, there was a certain initiative, where if I can touch it, from a physical perspective, well, I can grab a device and then I've got your configurations potentially, which is a vulnerability basically. And, now that we're talking about IoT in the same fashion, if these are devices from a physical and that hardening, not only from an environmental perspective, but hardening from a security perspective, if I can grab a device that is collecting data, depending on the regulatory requirements, a drone, for example, something that's not necessarily tethered, right. There's some security concerns on that. And that's something that, even being a security nerd, that I don't typically think about. If somebody grabs that, what kind of data is compromised? Or is that the point of failure for that particular, train that's got to keep checking the tracks? If somebody were nefarious and wanted to take the drone out, how does that affect the overall process? Just things that I hadn't thought of, does that expand into the data protection realm? It has to some degree. That's an availability issue, right?
Absolutely. So hardening, not only from an environmental perspective, but a security perspective, is very important. And it's, we've seen it be an interesting fine line to walk, because you've got to make it hardened and secure, but a lot of times you got to make it easy for these people in the field who are not traditional technologists to replace when something goes wrong. We have a retail customer where we're shipping IoT devices out, and fry cooks are plugging them in. And so you've got to make it easy enough where, hey, connect the purple wire to the purple port and then connect the power here, but also secure in a way where if somebody does decide to walk off on with that, they can't access the data, or it's meaningless without the complete stack, so to speak. So, things like encryption become important, both data at rest as well as data in flight, and all of those considerations that we maybe don't have to consider when that data is locked behind our four walls.
I think we need to think about hardening, and it's again, different than the concept of hardening within a data center. Sometimes hardening is I can accept losing this thing, and you have to design for that. So maybe you've got two things. Maybe you've got such small little parts of the stream, that if this thing is lost to the internet, it isn't going to destroy you from a security perspective. And you have to think about those things up front so that when you put the whole system together, it is complete, giving people what they need, but it can be secure and it can withstand certain elements of failure throughout the whole pathway.
Yeah, that's an interesting point. And, you made me think, I think you were talking about the fry cook, installing on-premise device kind of thing. And that, makes me think that not always do we have this, segmented infrastructure for the IoT devices that are coming in. We're shipping a bunch of stuff out, point of sale systems or whatever, and let's talk about the actual usability of what we're trying to accomplish here. We send these things out, they get plugged in, they're using other infrastructure. What are some of the techniques that we've got to deal with related to that from a data protection perspective?
Yeah, absolutely. We especially see this, as I've mentioned, in retail space where square footage is very important. They have it packed with every single product they could imagine, because every inch you take where you're selling something is money to the company. Every inch you take where you're hosting infrastructure is a liability. So we've from a hardening perspective, we've seen things like attaching to walls and attaching to ceilings, and how do they survive when they're stored next to the soda syrup or literally above a fryer. I mean, these are all considerations that we have to look at when we move into this kind of infrastructure at the edge type of conversations. And I think data protection becomes an even more important conversation then, because even though they're hardened, things still do go wrong, water spills, whatever the case may be, and this is damage. So how do we protect what's out there, and how do we ship it back to a centralized location? And an important conversation becomes protecting the metadata you're generating out there. Maybe the data itself is not overly important. It's processed at the edge. That's all fine. But I need to get that metadata somewhere else so I can do more of those deep analytics and business intelligence around that. So that becomes the second third of the conversation here.
And that reminded me, John, when you were talking about the conversation you had with your neighbor, and to your point just now, Chris, is that, the data that's collected maybe by one device, when aggregated, becomes a different classification level because of that aggregation of that data, right?
Yeah, again, what the speeds of one particular wind turbine is probably not a big deal, but if you aggregate one field, then you get a sense of what they're generating, and if it's a competitive analysis situation, you're trying to determine if you're able to generate this power and are you charging less than your competitors. This is all the stuff that you don't want to share, but again, back to a single tower, it may not matter quite so much.
Yeah. And what kind of strategies, who do you find yourself talking to about these things? And that's, I know I ask these questions all the time, but I think the folks out there kind of, who are the people thinking about these problems in the business? Is it more of the folks that have the application that needs to run on these devices? Or is it more the infrastructure folks that have to support those workloads? I would love to hear it's a consolidated team of everybody, but I have my doubts related to that actually being the case.
Yeah, I still think a lot of that falls on traditional operations and IT folks, just because they've been in that mindset for so long. Not to say app developers don't consider that as they're generating or writing the apps to generate this data, but I think it's a little bit of not my problem. I'll put it out there, you protect it type of mentality. Honestly, what we see a lot of is it's a combination of IT operations and security operations, because there's the traditional protecting the data from, hey, I need backups, I need replication, I need to secure it. But there's also the, as we mentioned earlier, a lot of data that's generated is personal identifiable information. And there's things like GDPR and other regulations that are that deal with the very strict storing and transmittal of that data. And so security often gets involved with, are we backing it up, but do we have a way to comply with these regulations when somebody submits a correction or asks for what data this company has on them, all of those GDPR goodness. I often see it as a combination of those two groups is where it falls mainly on.
So, I was just my brain wanders quite a bit. That's just how I roll. But I think that you just made a kind of an interesting point from a GDPR perspective. We work with a load of clients from a PII perspective. CPA and the other US regulations are obviously driving this conversation as well.
Mm-hmm.
But, for example, and, like Google Street View, there was a time where it was pretty much, hey, we just had the Google Street View. Now they're, blanking people's addresses out or license plates out or on requests, different things going on like that. And I'm thinking, with a lot of different camera-based IoT solutions and those kinds of things. And to the point that John was just making, you've got one camera that has data, but then you've got 3,000 cameras across a city that are gathering information and potentially can track, that wasn't what the design was, but maybe I can track me walking from my house all the way to work or all the way whatever I do after work and whatever, and aggregating that information. That becomes an interesting thing. I think there's, and then there's a data lake that anybody we charge access to, that anybody could come in and do analytics against that metadata that's been created that tracks my face and can space specifically the GPS coordinates that my face was tracked over a certain day, right? So now we're getting to a place where maybe we haven't even thought about what we're dealing with from a data perspective.
Well, and on top of that, in this I won't say post-COVID world type yet, but what we're seeing is a lot of thermal cameras being installed in businesses because we have to track how people are feeling and how do we take temperatures of large groups of people walking in and out of the mall or a business or whatever the case may be. So not only are those cameras tracking your location across the city, but now they're also sort of tracking your health as you're walking into these places. So, what regulations are there around that, and how do we secure the access and to that data as well?
Yeah, I mean, if we consider, go ahead, John.
I was going to say, again, the idea of the aggregate of that data is now much more critical. So it's not just storing the data, backing up the data, the access controls required for who's looking at that data. And do you have different levels of control for somebody monitoring a single site's worth of data for somebody who can access the data across the whole city, for example? Because then you start to get into those kinds of surveillance issues.
Yeah. I mean, and right now, PII is classified as like name resolved to IP address to email address. I mean, that could be considered PII depending on the circumstance, right? Mm-hmm. Well, what about my temperature? That sounds like some personal information. So we're getting into places. I'm not trying to be a conspiracy theorist or anything, but we're getting into places now that I think that the more we go down this realm because we're at a point now where the ability to collect it is a lot easier now. And I don't think we've really tapped into that. All right, I'll take my tinfoil hat off, but let's talk about, some from a security perspective, and data. So things like ransomware. Do we really feel like ransomware is something that IoT is insulated from?
Absolutely not. I don't think anybody's safe from ransomware, to be honest. And a lot of times when this IoT devices are collecting data, in a lot of cases, it's a competitive edge over your competition. Bluetooth beaconing in retail stores, or as you mentioned, tracing movements through cameras and things like that. We're seeing a lot of competitive edge, IoT being used for competitive edge, and as it becomes more and more important, that becomes a larger target for ransomware. So I think there hasn't been a ton of attacks yet because this industry is still somewhat new. But as it becomes more mature and the use becomes broader, I think we're going to see more and more ransomware attacks against this type of data. So it's definitely not safe. It's definitely a good argument for having the data protected, both from a physical security perspective, but also backups of the data, because these threats are real.
I think too, it gets into both the protection of the data. What does the loss of the data mean to the organization? That might be why they're being asked, to pay a ransom. But the other piece is, what is the difficulty to recreate the system? So again, this idea that if you have 100 sensors and you could destroy them all, and in an hour they're all back up or replaced, because your system is resilient, that's going to give the client more protection in terms of how they deal with these things, as opposed to looking at a situation where things are down and they're like, man, it's going to take me 3 weeks to put this thing back together. That's going to leave the client in a different situation. And we need to do all that we can to help design the systems that are more resilient to protect against those things.
Mm-hmm.
I love that. Because that's the thing. I think some of the initiatives that we've got going on, Chris talked about competitive advantage and those kinds of things. Competitive advantage is a nice to have. You know what I'm saying?
Sure.
So if we design these things out there from a nice to have, at a certain point, they're going to be a critical. We've got to have these things, especially we were talking about healthcare and other things, where if these things aren't designed with that level of resiliency and availability, I mean, we think about all of those things that from a security perspective, we talk a lot about confidentiality, but that whole availability aspect, once we really depend on this to run our business, that's where that thoughtful infrastructure and data protection aspects really do come into play. And that planning that you made ahead of the game is really going to pay off.
Absolutely. I mean, and I think we're already seeing that. We have retail customers that design the layout of their stores based upon the data they collect of shopping habits. And, to John's point, is that detrimental if it goes down for a few hours? No, but you start talking about down for weeks and months, and that's critical data you're starting to lose from your business. And so I think we're at the cusp of it, making that turn from nice to have to I run my business off of this information. So.
We used to talk about security in terms of a firewall or a moat around a data center. And you create this model of, hey, as long as we have the world's best firewall on the outside, we're safe. And you didn't care what was inside. And any host could talk to any other host. And you didn't really segregate things at all. Well, now, again, the safer model is much more segregation down to the VLAN level, down to a host is only allowed to talk to certain other hosts. We have to take that same model and expand that out to the edge of all of these pieces. Otherwise, we're not doing as good of a job as we should be in designing these systems.
Yeah, it's almost like bringing that concept of zero trust to these devices. Consider them hostile because they're not within the confines of my protected walls, and they could just be as hostile as a rogue user. So absolutely.
No, I love that. I think that's probably a place to end. Because what I want to drive at here is, especially with the stuff that we're talking about, the earlier question I kind of asked was, there's a lot of the same problems. We shouldn't consider IoT separate and distinct from the rest of the business, especially when it's on the same in the same environment or processing data that's going through our entire environment. It's something that should be thoughtfully considered as we're first that there's that let's see if it works kind of thing, but once we start relying on it's got to be included with all the other aspects of regulatory compliance, of availability, of data protection that we have with our manufacturing floor.
Mm-hmm. Absolutely. And unfortunately, it's just storage and data protection are just a small piece of that puzzle. We haven't even touched on compute or networking or anything like that. So,
yeah. So now that we maybe painted a grim picture, what do we say to folks that are out there? So they're listening, they like what they're hearing, they think we brought up some good points. What's the good word that we've got for folks that are out there tackling this stuff?
Start with your desire and let us help you piece it together, and just realize that we're going to start with the things that we've been doing for years, but we're going to be adding additional layers of analysis in terms of how we put this thing together to be resilient, to be hardened, to be safe, and to be effective.
Yeah, John hit the nail on the head there. I was going to say something very similar. I mean, the the foundations of what we've done in the past still apply here. There's just some new variables sprinkled in, and the more you're aware of these variables up front, the easier and the less painful your IoT journey will be in the long run. So your Jurassic Park quote still applies here. And if you determine that you should, go down the right path and do it the right way, and go in eyes wide open. So I think that's the best advice here.
Yeah, I love that. And I think, again, not addressing these problems in a siloed fashion,
Right.
Data protection separate than infrastructure, separate than the app dev process of dealing with it, all of it as a whole, and how throughout the whole process how that data is created, travels, used, destroyed, all of those things, and the resiliency required and infrastructure required in order to support it.
Absolutely.
Exactly.
Awesome. Well, thanks, guys. It's been fun. I felt like we could probably go on another hour and a half, but wanted to keep it palatable for folks out there. We really appreciate you guys listening. And of course, we actually modified this session based on some comments that you guys made. We love to hear from you. Please feel free to comment on this. And if you'd like to know more about what we do here, please visit us at insightcdct.com. Thanks, gentlemen. It's been fun.
Thanks, Jason.
Thank you.